Hello and welcome to Wireshark Certified Network Analyst video course. In this video, we will learn one of the most used functions in Wireshark, display filters. We will start with the definition of display filters. Then we'll take a look at the expressions and how they can help you build the right filter. After this, we'll learn the display filter syntax. Next, we will take a short look at filter macros. We will also learn some common mistakes and how to avoid them. And finally, we will learn how to edit defilters by ourselves in a text editor. To practice the skills learned in this video, I prepared for you a lab and a quiz which you can take at the end of this lesson. Whereas capture filters use BPF syntax, display filters use a proprietary Wireshark format. All display filters except the VoIP ones use just lowercase characters. They are used to avoid the needle in the haystack issue by focusing just on traffic you need. Display filters can be applied to both live captures and saved files, and they don't modify the captured data. Some of the basic display filters are TCP, UDP, ICMP, BOOTP, ARP, and DNS. Display filters can be based on packet characteristics, not just an actual field. Those characteristics still appear in the packet details pane, but they're included in the square brackets. Some examples of such filters are frame.timeDelta, IP checksum bad, TCP next sequence. Using operators, you can create display filters based on field contents. For example, TCP flags equals 0x20, http.host equals www.google.com, IP address equals 192.168.0.1. Display filters also allow filtering on any byte you want. It uses the same format as capture filter proto expert size. For example, IP 14:2 equals 96.2c. However, those filters are seldom used because Wireshark has most of the necessary data to filter in fields and virtual fields, which are written in square brackets. If you don't remember exactly the field name, type in the filter bar the part of the filter you remember. For example, we want to look for the user agent field. We know it's located in the HTTP header, so we type HTTP. Next, we type the dot, and we can see a list of all the fields in the HTTP header. We can scroll down and see the user agent filter. Click on it to autocomplete. To apply a save filter, press the filter button, select a filter you're interested in, and press OK. The filter will be applied. From the Save Filter menu, you can edit, delete, or create new filters. Use Expression button to guide you through the filter creating process. Some fields have predefined values, like ftp.response.code. Another way to create display filters is using the right click. Select any field of interest, right click on it, and choose either Apply or Prepare a filter. The only difference is that applying it will make the filter active, but preparing it will just write the string in the filter toolbar so you can modify it and apply it afterwards. By choosing selected or not selected, the string written in the toolbar will be replaced, and by selecting other options, you combine the current string and the field you selected with operators, creating a new filter. You can also copy the filter string in the system buffer by selecting Copy as Filter. This is useful for creating complex filters, coloring rules, or copying between different Wireshark instances. There is a fast way to filter conversations as well. To do this, go to Statistics, Conversations, select any conversation you want, right-click on it, and select Apply or Prepare as Filter. You can choose the direction of this conversation as well. From the same right-click submenu, you can find a packet or colorize a conversation. The same can be done with endpoints, except there will be no direction. An even faster way to filter a conversation is by right-clicking on any packet in this conversation and selecting Conversation Filter, then the desired layer. As we've learned in previous videos, in the status bar you can see the field name when it's selected. You can use this feature to create filters and learn their names. Display filters can be combined with the following operators, written either as symbol or text. Contains operator just looks for the string inside the layer. So for example, HTTP contains zip. We will look for zip string inside the HTTP layer and can be used to look for downloaded zip files. The matches operator works similarly, but it uses regular expressions. To learn more about regex, go to regular-expressions.info. This is a powerful tool to use to match complex strings. To filter all the packets with HTTP requests and ending in PHP, we will use this filter, where the $sign indicates the end of the string. So if PHP is found not at the end of a URI, packets won't be displayed. Parentheses can change the filter's meaning. For example, this filter will match DNS traffic from 192.168.0.10 and all the HTTP traffic regardless of the host, but the next one will match DNS and TCP traffic just from the host 192.168.0.10. Here's an example how to filter on specific bytes. If you want to display just the packets coming from Cisco devices, which have OUI equal to 00:01.43, we'll use this filter. As you can notice, when you type the display filter, the field becomes highlighted. It could be red, green, or yellow. Red means the filter is wrong. Green, that it's correct. And yellow means the syntax is correct, but logically it may be wrong. This happens when you use not equal operator. So for example, when you type this filter, it may seem correct, but it won't filter as wanted. This filter actually means that you're looking for a packet that has an IP address field that contains a value other than 192.168.1.140. There are two IP address fields in a packet, source and destination. If one of the fields has a different value, the packet won't be matched. Let's take another example with TCP.port. There are two fields which match this filter, TCP source port and TCP destination port. If we use this filter, it will match all the packets with a source port 80 and another destination port, all packets with a destination port 80 and another source port, and all the packets with both source and destination ports different than 80. However, packets with both source and destination ports 80 won't be matched. All the packets without a TCP header won't be matched either, because this filter implies that the packets contain the TCP port field. After learning this, if I ask you to build a filter which will ignore all the packets with TCP SYN flag set to 1, you should probably know that this filter is wrong. Why? Because it means look for a packet that doesn't have the TCP SYN pit set to 1. ARP and DNS traffic will match this filter as well. They don't have the TCP SYN bit. The correct way to do this is by using the not equal operator. This happens with all display filters which relate to more than one field. To write a filter which will ignore all packets to or from 10.0.0.1, use this filter, with negation at the beginning of the expression. When the expression you wrote is related to a single field, like IP source, IP destination, TCP source port, you're safe to use not equal operator. Note that some display filters will be wrong even if they are highlighted in green. For example, HTTP and ARP. It's impossible to have a packet with both ARP and HTTP headers. Let's take a look at some display filter examples. To match an IP address in any source or destination, use this filter. To ignore all packets with source or destination IP address, use negation. IPv6 addresses are filtered this way. You can indicate direction using source or destination. You can filter traffic based on the name, but it will work when network name resolution is enabled. To display traffic to or from an IP range, you can use this filter. The same works for IPv6. To filter traffic from or to a subnet, use CIDR notation. If you need to filter on a specific protocol and you don't know exactly the display filter, go to Protocol Hierarchy, right-click on desired line, and apply or prepare as a filter. You can also find frames with this protocol or create a coloring rule which will match selected protocol. We've already discussed about filter expressions. Try to use them whenever possible. This is the fastest way to apply a display filter. Filter expressions are stored in Preferences file after Filter Expressions label. You can edit the list or share it with other computers. Display filter macros are designed to avoid typing repetitive strings when you use filters with the same structure but different values. One such example would be filtering on multiple ports. With 5 ports, we will have the following filter. To create a macro which will simplify this task, go to Analyze, Display Filter Macros. Click New, assign a name to this macro, and find out what we should write in the text field. We need to take a look at the filter we need. Now, replace each variable with a $sign and a number, starting from 1 and increasing each time. To apply this macro, write in the filter toolbar $, curly brackets, macro name, colon, and the variables separated by semicolon. The number of variables should be equal to the one in the macro. All the macros are saved in the personal configuration folder in the file dfilters macros. In the following format, quoted macro name, comma, and quoted macro filter string. The saved display filters are stored in dfilters, and they are written in this format: quoted filter name and unquoted filter string. Remember that all the configuration files in Wireshark must end with an empty line, otherwise the last line won't be read. In this video, we've talked about a very important function in Wireshark, display filters. We've defined them, we've learned how to use expressions, display filter syntax, display filter macros, how to avoid common mistakes, and how to handle dfilters and dfilter macro files. That's all for today. I hope you enjoyed this video. See you next time. Bye.